Hello there, Mr. Dodd, back with more information for some pre-calculus, help you get through the course. It's going to be a tough one, so I want to provide all the help that I can. In Standard B12, we're going to be talking about parallel and perpendicular lines. Basically, parallel lines are two lines that never touch. Perpendicular lines cross at a 90-degree angle. Parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes, which means switch the sign and flip the fraction. So if my initial slope is 2/3, my parallel slope is 2/3, and my perpendicular slope is -3/2. So flip the fraction, change the sign. So determine the slope of your initial function. Find the slope for your new function, either parallel or perpendicular, depending on the one. And then write the new equation using the slope and any other information. Anyway, so my example, you are welcome to try it on your own. It shouldn't be super difficult. So if you want to try, go for it. Pause the video, and then you can check. Y equals 2x plus 1 and goes through the point 2, 3. So that means y equals 2x, that's my slope, my initial slope. So my parallel slope is going to be the same. Because I have a slope and a point, I'm going to use point slope form. So y equals 2 times the quantity of x minus 2 plus 3. That'll give me my equation in point slope form. Again, I have the y coordinate on the right, which is fine. That way y is isolated. And then perpendicular, instead of positive 2/1, I would use negative 1/2. So y equals -1/2 times the quantity of x minus 2 plus 3. So what I asked you to do is graph all three lines on the same coordinate grid. So y equals 2x plus 1. So 2x plus 1 is going to give me this guy right here, like that. If I go to the point 2, 3, 2, 3, and then do up to over 1, this would be my parallel line. And I just wanted to give a visual on what parallel and perpendicular mean. Notice I'm going through the point 2, 3, and then I am parallel to that line. And the next one goes through the point 2, 3 as well, but I go down 1 over 2. Okay, down 1 over 2, and then if I connect those dots, notice that I cross at a 90-degree angle. So that's why I wanted all three on the same coordinate grid. That way you could see what parallel lines look like, never touch. Perpendicular lines look like, cross at 90 degrees. Anyway, hopefully that's helpful with parallel and perpendicular lines.